Hi, I'm Greg Rowland, founder of Sandfly Security. In today's video, we're going to talk about a file-based attack on Linux that's very simple, but still used today by attackers, and that's hiding a binary under system executable directories on a Linux host. The attack is really pretty simple. Essentially, I take my malicious file or my payload data, whatever it is, and I put it under a system executable directory such as bin or user sbin, and it just sits there ready to be used. Now, this is the type of attack that we call a dormant attack. And the difference here is we have the other side called an active attack. A dormant attack is something that was done to the system, but it's not necessarily running right now. This is as opposed to an active attack on Linux, which basically is something that's happening in the process space right now, and you can actually see it happening. Dormant attacks are very, very common on Linux, typically done because attackers are pre-positioning payloads, or perhaps they have something that's going to be run in the future, but they don't want it running right now. But for whatever the reason is, the dormant attack can sit around for a long time without being seen, and in today's demonstration, that's exactly what I'm going to show you. So we're going to go to the screen right now. We're going to go to our Sandfly user interface. Sandfly is an agentless Linux endpoint detection and response product. Plus, we do a host of other things such as password auditing, SSH key tracking, drift detection, and more. But for today's demonstration, we scanned one of our test systems here, and we found that it had a single alert. This alert here is a file binary was hidden under the bin directory. And we're going to read here what it says. Basically, the file user bin.config was found under user bin as a hidden Linux executable. Hidden executable file names has a dot as the first character, are suspicious and not part of the normal Linux installation. This is true. Pretty much, you are not going to find a Linux distribution that ships with a hidden binary as part of it. This is a very unusual thing to do. Now, there are some programs out there from third parties that might occasionally use a hidden binary. I don't know why they do it. I think it's an incredibly bad practice and a very dumb thing to do, but for whatever reason, we have to deal with it. But 99.9% of the time, if you see someone hiding a binary in a Linux system, you need to go take a look at what it is going on. Now, on this system here, we found it under this user bin directory here. It's calling itself .config. That immediately gets my suspicion. We can look here for the raw result data, and I can see everything about it. I can see when the file was made, who owns it. I can see the full path to it. I can see what flags, such as links. There's some other interesting things here as well that we'll get into as we look into the host. The other thing too is we could pull up, again, file hashes if you want to look this up in a malware database. That's not terribly reliable for Linux, which I got into in other videos about why hashes are unreliable and shouldn't be used, but you might get a hit on it. Could be something you could try. But basically what we want to do now is we want to take a look at this host. So I'm going to switch over to my terminal over here. And we know that we're in the bin directory. Here, I'll go to user bin, which was the actual location here where the file is. And the first thing I'm simply going to do is ls-al.config, because that's the name of the file. And sure enough, we see it here. A couple things here. I can see the date that it was made. Unless they time stamped it, this might actually give you the actual time of intrusion that happened. In this case here, I'd say this is probably pretty reliable. This is what they did. I can see it's about 67K in size. And here I see that it's owned by root, made by root, which means that whoever did this likely was the root user, which means I've probably had a full system compromise here and root has been compromised. And that's actually always my advice. If someone has gotten on the system, you should just assume root has happened. Now, a couple other things I could do on this. I can use the file command. And this is simply going to tell me the type of file it is. In this case here, we see it's an ELF file, 32-bit. This is on an ARM system because this is a Raspberry Pi that has been compromised here. And we can see all the information about if it's statically linked, dynamically linked, and so on. Another interesting thing that we'll do here is I like to sometimes list the file attributes of a file. Here, lsattr. In this case, I see something interesting. I see it's config, and I see this file here we discussed in another video. This I flag means that set as immutable, which essentially means someone made this file, so it'd be difficult for you to remove. Once that immutable flag is set, only root can remove this file. This is, again, commonly done by some malware to maintain persistence, but it's an additional thing to let you know that there's probably up to no good on this system. The other thing you can do too is you can get the SHA-1 sums, which we already discussed. And again, you could take this onto a database if you want to look into it. Well, one other thing I like to do too, if I'm investigating a suspicious file, is I'll just run lsof, and I'm going to grep it through the name of the file. So in this case here, this is going to list all the open files on the system. This is going to show me all the processes that have a file open of the name .config. The slash here basically just escapes that config. And when I hit enter here, I see immediately that I actually have a process running. It's process 1884, and that process is running on the box. It has this file open. I can see here the various libraries it has open, and down here, even more worrying here is I have a TCP port open of 4444. So basically, that's the roundabout way of saying that if you see a hidden binary under Linux, you should probably go take a look at it. This file definitely has all the attributes of something that's up to no good. It's a hidden file in a system executable directory. That file that was created recently, it had an immutable flag attribute set on it, and it's currently running on the system with a network port listening. Everything about this says that this system needs to be isolated and full incident response needs to happen on it. So anyway, I'm Craig Rowland from Sandfly. Hope that helps you out in looking for hidden binaries. Dormant attacks are very important to look for as well, because in this case here, that dormant attack can turn into a live attack running on the host. But sometimes dormant attacks can sit around for a very long time. So it's good to look at both on your Linux system. Sandfly can help you with that. If you're interested, please check out our website for a free license, and check out our other videos as well for more information on Linux security and incident response topics. Thanks again for watching, and bye.